next I want to talk about some characteristics of f of x equals log base a of x. So the points when x is 1 over a, y is negative 1, when x is 1, y is 0, and when x is a, y is 1 are always on our graph. Well, why is this? If I have log base a of 1 over a, that's going to give us negative 1. If I have log base a of 1, that's going to be 0 because remember, any number other than 0 to the 0 power is 1. And if I have log base a of a, that's going to give us 1 because a to the first power is just a. The opposite of these points is on our inverse function, which would be the exponential of a to the x. If a is greater than 1, then f is an increasing function. This is going to be the majority of cases. If a is a fraction, then it is a decreasing function. Remember, a cannot be negative. As opposed to having the x-axis as a horizontal asymptote, we have the x-axis as a vertical, the y-axis is a vertical asymptote. Our domain is 0 to infinity, and our range is negative infinity to infinity. So why don't we practice graphing a couple of these bad boys? So if I have f of x equals log base 3 of x, whereas before I took nice x values, now I want to pick x values that make sense for 3, like a ninth, a third, 1, 3, 9. So log base 3 of 1/9 is negative 2. Log base 3 of a third is negative 1. Log base 3 of 1 equals 0. Log base 3 of 3 is 1. And log base 3 of 3 is 2. I wanted to do more points so we could kind of get a flow of what's going on. So when x is 1/9, y is negative 2. So here's 1/9. We'll go right there. When x is 1/3, y is negative 1. When x is 1, y is 0. When x is 3, y is 1. And when x is 9, y is 2. So it's like up over here. So here's our function. We've got a vertical asymptote at y equals 0. At x equals 0, which is our vertical asymptote. Our domain goes from negative infinity to positive infinity, and our range goes from I messed that up. Okay, my domain, which is all possible x values, goes from 0, right? We're looking at our x values, to positive infinity. And my range now goes from negative infinity to positive infinity. The inverse function of this, f inverse of x in this case, would be 3 to the x. And it would be reflected over the y equals x axis. Bonus information, previously not included. What if I have log base 3 of x minus 2? Remember that this is a shift. What type of shift is this? This is a horizontal shift. It's a horizontal shift to the right, too. So now my graph is going to be shifted to the right, too. Let me show you what that looks like. I'm going to pick some odd x values. I'm picking x values that make sense. So if I plugged it in, so for example, if I have x is 3, 3 minus 2 is 1. And we can take log base of 1. We can also take log base of 5. 5 minus 2 is 3. Log base of 11. If I have x is, I can only take the log of positive numbers. So I could have x is 2 1/3. X is 2 1/9. Let's plug these in. So if I have log base 3 of 2 1/9 minus 2, that gives me log base 3 of a ninth, which is negative 2. If I have log base 3 of 2 1/3 minus 2, that's log base 3 of 1/3, which is -1. If I have, this should be 3, sorry. If I have log base 3 of 3 minus 2, that's log base 3 of 1, which is 0. If I have log base 3 of 5 minus 2, that gives me log base 3 of 3, which is 1. Log base 3 of 11 minus 2 is log base 3 of 9, which is 2. My graph has been shifted to the right too. I now have when x is 2 and 1/9, y is -2. When x is 2 1/3, y is -1. When x is 3, y is 0. When x is 5, y is 1. My graph looks like this. My vertical asymptote has shifted to where x equals -2, and so thusly has my domain. My domain now goes from -2 to infinity. Sorry, +2 to infinity, right? Because I'm looking at all possible x values. And my range has what's unchanged, goes from -infinity to +infinity. Next, we need to talk about e. E is an irrational real number. It is not a variable. It's about this. If you plug it into your calculator, there's a special button for it. And it's found by taking the limit of 1 plus 1 over n to the n as n approaches infinity. Okay? This is its notation. What you need to know is that it's not a variable. It's also used to develop the natural logarithm. So for all positive numbers x, the natural log of x equals log base e of x. We also have another log. This is the log button you'll see in your calculator. If you just see log by itself without a base, that means log base 10.